Here's that Mars problem right here. So you can see that Mars actually loops. Well, that's how they were trying to ground Mars's behavior in space. So this is about Ptolemy, actually, but he put that loop in there, or you can see at the bottom there too, there's a loop in the box to try to account for when Mars backs up. So it's interesting. So he also talks about many of the planets. So he goes through Mars, and he goes through Venus, and there's a couple interesting quotes here about Mars that I wanted to share. So he says earlier that he says, why is there so many people out there who think there are Martians? Why not Plutonians or Jupiterians or whatever? And he says the reason is that Mars is close to us, but also because Mars is a lot like the Earth. And so people think that, well, if people emerged here, then why couldn't have people emerged on Mars? And there's also the speculations about that people at one time were on Mars, and at one time that's kind of spooked the world. There was evidence of roads on the Mars. It looked like there were roads. And I think they found out they were old rivers or something. But anyways, that spooked a lot of people for a while about Martians. And that's why there's all kinds of Martian movies. And you may know that, I think it was H.G. Wells, his Mars Attack, or I can't remember what the story is called now. Yeah, he has a story about Martians invading the Earth. And he had first read it on the radio as like a story. Used to be the case, and you can still find them on YouTube. Stories were read on the radio, and because there was no TVs at the time, what you did at night was you couldn't sit and watch TV as a family. You'd listen to the radio and listen to people read stories on the radio. And H.G. Wells apparently read the story about Martians attacking the Earth, and people thought it was real. People thought that the Earth was being attacked, and this was a play-by-play on the radio. So that's an interesting fact. But anyways, this is on page 95. He says that because the Martian atmosphere is only 1% as dense as the Earth's, a very large parachute, 18 meters in diameter, was deployed to slow the spacecraft as it entered the thin air of Mars. The atmosphere is so thin that if Viking had landed at a high elevation, there would not have been enough atmosphere to brake the descent adequately. It would have crashed. I just thought that was an interesting fact about Mars. I guess the air is really, really thin. And if there's not enough air then resisting you as you fall. So if you fall on Mars, you just fall flat. There's no air around you to catch you. And therefore the parachute's got to be huge to catch a Viking satellite landing on Mars. Because there's just so little air to catch the parachute. You just have to have a huge parachute. So, and this is more on Viking's mission to Mars. This is on page 98. But for so dangerous and mysterious a planet as Mars, there was also at least an element of luck. We knew we had chosen dull places, but we could hope. So this is about where the Viking satellite landed on the planet. They wanted to find some interesting things and not just be in some dull area. The first pictures taken by the Viking 1 lander was of one of its own footpads. In case it were to sink into Martian quicksand, we wanted to know about it before the spacecraft disappeared. The picture built up line by line until, with enormous relief, we saw the footpad sitting high and dry above the Martian surface. Soon other pictures came into being. Each picture element radioed individually back to Earth. So I thought that was kind of interesting. You land on this weird planet, you have no idea where your little toy went. It's just landed somewhere, and I guess it's receiving signals back and forth, so you know it's not destroyed, but you have no idea where it is. So the first thing you want to take a picture of, you don't want to take a picture of the sky or something, because you could then just take a picture of sand, because the thing is buried. So what you do is you take a picture of something that you know what you're going to see for sure, because otherwise on Mars you have no idea what you're going to see, right? You've never been here before. So let's take a picture of something that we know what we're going to see. So let's take a picture of one of its footpads. So it did, and you still see a footpad, so okay, thankfully everything's fine with it. Now you can start taking pictures of everything else. So that's what they did to start out. So more interesting stuff for life on Mars now. So it mentioned some studies they did in Antarctica. It says here that Helen Simpson Vishniak is the scientist. Large rocks returned from Antarctica in that expedition, examined by Friedman, turn out to have a fascinating microbiology. 1 or 2 millimeters inside the rock, algae had colonized a tiny world in which small quantities of water were trapped and made into liquid. And so the speculation is that if this can happen in Antarctica, a pretty harsh environment, maybe this could happen on Mars too. So I'll continue. Each Viking lander was equipped with a sample arm to acquire material from the surface and then slowly withdraw it into the innards of the spacecraft, transporting the particles on little hoppers like an electric train to 5 different experiments. One on the inorganic chemistry of the soil, another to look for organic molecules in the sand and dust, and 3 to look for microbial life. When we look for life on a planet, we are making certain assumptions. We try, as well as we can, not to assume that life elsewhere will be just like life here. But there are limits to what we can do. We know in detail only about life here. While the Viking biology experiments are a pioneering first effort, they hardly represent a definitive search for life on Mars. Each of the 3 microbiology experiments asked a different kind of question, but in all cases a question about Martian metabolism. If there are microorganisms in the Martian soil, they must take in food and give off waste gases, or they must take in gases from the atmosphere and perhaps, with the aid of sunlight, convert them into useful materials. So we bring food to Mars and hope that the Martians, if there are any, will find it tasty. Then we see if any interesting new gases come out of the soil, or if we provide our own radioactively labeled gases and see if they are converted into organic matter, in which case small Martians are inferred. So some interesting stuff about the kinds of experiments that they were doing, and of course also about how much is true about life here that could be true about life there. This is on page 104, so this is going to continuing on the search for life. It says that it is too soon to say that all the Viking microbiology results can be explained by inorganic chemistry, but such a result would no longer be surprising. The clay hypothesis hardly excludes life on Mars, but it certainly carries us far enough to say that there is no compelling evidence for microbiology on Mars. So that was the conclusion from that, from the Viking experiments. And now more on Mars. And this is actually talking about the invasion that I mentioned before. It's on page 106. The Viking exploration of Mars is a mission of major historical importance, the first serious search for what other kinds of life may be, the first survival of a functioning spacecraft for more than an hour or so on any other planet. Viking 1 had survived for years. Some scientists want to send an automatic device that would land, acquire soil samples, and return them to Earth, where they could be examined in great detail in the large, sophisticated laboratories of Earth, rather than in the limited, miniaturized laboratories that we are able to send to Mars. However, it carries with it a novel danger: back contamination. If we wish on Earth to examine samples of Martian soil for microbes, we must, of course, not sterilize the samples beforehand. The point of the expedition is to bring them back alive, but what then? Might Martian microorganisms return to Earth pose a public health hazard? Yeah, so that's an interesting idea of, okay, so we'd like to study stuff out there, but what if it comes back here and it just leaks out and destroys our population? So there's a fear about it, a fear of the unknown and the fear of the consequences that it may have, because something that's just like what happened with Native Americans in the New World period and the deaths from disease that the Europeans brought over. The same thing could happen with Martians and Martian microbes coming to Earth that, of course, no Earthling would be adapted to and could be a serious health hazard. So that's also an interesting problem for what we would like to do, studying the life of other planets. So here's some more stuff on Mars. He's, of course, Carl Sagan is a promoter of science, and he wants to do more stuff on Mars. So he's kind of saying here that if we televise these things, then we'll increase the public support of science. So he says on this on page 108, public interest in such a mission would be sizable. Every day a new set of vistas would arrive on our home television screens. We could trace the route, ponder the findings, suggest new destinations. The journey would be long, the rover obedient to radio commands from Earth. There would be plenty of time for good new ideas to be incorporated into the mission plan. 1 billion people could participate in the exploration of another world. So that last bit, of course, is amazing. But the other interesting part about this is that it could be like, you know how on sports channels, you've got all kinds of pre-game and post-game commentary. Well, space could have been like that. Space travel. They could have had all these pictures come back from Mars and actually have a space channel where they talk about the pictures, and we have some pre-picture commentary, and then we look at the pictures, and then we see some post-picture commentary, something like that. And that would get more people interested in donating money to science, or I guess letting the government tax them more, I don't know. But NASA's gone, I think, now. So now it's more private enterprise, but still there could be all kinds of interest if the public were more engaged in the findings and the curiosity, the speculations of scientific discoveries. So if that was done, that could increase public interest in it. Now, the next thing he says here I don't agree with, but I'll read it anyways. He says that there are so many examples of human misuse of the Earth that even phrasing this question chills me. If there is life on Mars, I believe we should do nothing with Mars. Mars then belongs to the Martians, even if the Martians are only microbes. I think that's a stupid thing to say, but just kind of a silly environmentalism, like the only thing wrong with the environment is that we're in it. That kind of real misanthropy I don't agree with. But okay, on the next page, 109, he's talking about whether the Mars could be made livable. A lovely world, surely, but there is, from our parochial point of view, much wrong with Mars, chiefly the low oxygen abundance, the absence of liquid water, and the high ultraviolet flux. The low temperatures do not pose an insuperable obstacle, as the year-round scientific stations on Antarctica demonstrate. All of these problems could be solved if we could make more air. With higher atmospheric pressures, liquid water would be possible. With more oxygen, we might breathe the atmosphere, and ozone would form a shield to shield the surface from solar ultraviolet radiation. So what we're talking about here is terraforming, which if you play any computer games, you'll already know what the concept is. But it's changing the planet to be able to have life. And of course that can take many approaches depending on what the planet is already. It may be that you have to live underground, but that just means that you terraform where you want to live. It also might be terraforming the air so that you can walk around and breathe. It just depends on the planet's circumstances. The terraforming that you do to a planet, it's not to say that in every planet we turn it into an Earth. That just might not be possible. But the terraforming simply makes it livable based on its circumstances. And so in this case on Mars, he's saying that all we have to do for Mars is we just need to increase the air. Now that's going to be not possible. So it's not as if we can just bring in air pumps or bring in oxygen tanks and just release them and then that'll be it. The atmosphere of Mars is also based on its gravity and its size. I believe the Mars is less dense than the Earth and therefore has less gravity, which means it has less of an atmosphere. And I guess 1% of the atmosphere. So that is definitely a problem. It may be, it's not likely that Mars will ever be breathable. We know that at least some terrestrial microbes can survive on Mars. What is necessary is a program of artificial selection and genetic engineering of dark plants, perhaps lichens, that could survive the much more severe Martian environment. If such plants could be bred, we might imagine them being seeded on the vast expanse of the Martian polar ice caps, taking root, spreading, blackening the ice caps, absorbing sunlight, heating the ice, and releasing the ancient atmosphere from its long captivity. We might even imagine a kind of Martian Johnny Appleseed, robot or human, roaming the frozen polar wastes in an endeavor that benefits only the generations of humans to come. So that is also an interesting way of terraforming. We just spread these plants around that will release the polar ice caps, and I suppose put more water vapor and more gases into the atmosphere. Again, I just don't know if the planet's density will prohibit pressure. So, but that's an interesting idea, of course. So this is on page 112. Getting off of Mars now, we're talking about traveling through Mars and speed over time.